This is Ham College, episode 32 for August 31st, 2017. Ham College is brought to you by Ikon. Heard it, worked it, logged it? Let Ikon help you make as many contacts as possible. And by hamstudy.org, a great way to study for your next license exam. Hi, welcome to another episode of Ham College. I'm Elmer Thomas.
I was going to say, and I'm Elmer Fudd, but I'm Tommy.
And it's good to be back tonight. You know, we got a hurricane going on out in the Gulf, hitting Texas as we speak.
A little bit between Houston and Corpus Christi, right?
Mm-hmm.
Yeah, Hurricane Harvey. So
we've got a radio tuned over here to the Hurricane WatchNet 40-meter frequency.
Yeah.
We were listening in a little earlier, just what was going on there. So, unfortunately, we're not going to be able to keep that radio here that long, Tommy.
Yep. Guess we'll give it away.
I think we will. We'll talk about that a little bit later.
Okay.
Yeah, we'll just leave it at that. We'll talk about it a little bit later.
That'd be good.
Well, what did we talk about last month?
We talked a lot about the band plan, and I believe we talked about resistors.
We did.
Resistance is futile.
Yep. We talked about both of those things. I think, and I could be wrong, but I want to say it's possible that I told you last month that we were all done with the band plan questions.
Yeah, I didn't really believe you at the time.
Man, and it was a good thing you didn't, because I was lying. We got more band plan questions tonight, but I think if you got the ones last week, you're not going to have any trouble with these. We're also, I think we got one resistor question left, maybe. I don't know why. Well, we should have...
Just one left over.
Yeah, we should have used it last month, but we're going to get into capacitors.
Okay, that should be fun.
And we're actually going to... Well, I've got my inexpensive old Tenma capacitor checker here. We're going to pull that out and just check some of the theory on these formulas and make sure that it's right.
Okay.
What have you been up to, Tommy, since the last show?
I really haven't done too much special. Just same old routine stuff.
Well, I went to Huntsville Hamfest this past weekend. Had another good time out there. I shot a little video. This year I didn't shoot as much video as we've done in years past. Did a few interviews that I thought were interesting, but I really got a chance and walked around the flea market this year, and I think I saw all of the flea market.
Yeah.
Which I've never done before.
I missed that. I did have something going on because I went out of town for my son's competition. He was in the strongman competition in Alabama. And so, anyway, I missed that because I was really counting on going.
Did they lift any cars down there?
No cars. They lifted a lot of weights, a lot of beer kegs full of rocks and all kind of crazy stuff. It was interesting. It was really hot, though.
Yeah. Too hot to be lifting beer kegs full of rocks on.
Mm-hmm. Yeah, no kidding. I'm not much of a drinker, but the beer kegs full of beer might not have been a bad idea if it was cold.
It would have been cooler than the rocks, yeah. I'm sure. Well, what do you say we get on in? Oh, before we do, we want to mention the chat room. Anytime we're doing any kind of show here on Amateur Logic, we've got a chat room going on, and where is that?
AmateurLogic.TV/chat.
And if you notice us look down every now and then, that's what we're doing. We're glancing down at the chat room to see what's going on in there. a lot of folks in there having a good time, and it's always great to have them there. As we progress through the questions here, they will answer in the chat room there live what they think the answer is to it, and we'll look over there and compare notes to see if we're thinking the same thing. So.
If you're watching the live feed here, the live stream, if you're not in the chat room, you're missing half of the fun.
Yeah.
So anyway, if you are, go join them over there. I think you'll enjoy it.
I think you will. Okay, first question tonight. Which of the following frequencies is within the general class portion of the 75 meter phone band? A, 1875 kilohertz.
B, 3750 kilohertz.
C, 3900 kilohertz.
Or D, 4005 kilohertz.
Okay, Tommy, I think you ought to be able to answer this one.
Okay, which is within the general class portion? Then, typically, the general class is going to be the higher end. If I remember, 75/80 meters ends at 4 megahertz, if I'm not mistaken.
Same as 4,000 kilohertz.
Yeah, so that means D is not within. So I'm going to say C, 3900 kilohertz. I probably just blew it.
No, I think you're right. I think you're right, and a lot of people in the chat room do. Not everybody agrees with your answer. So let's just take a look here and see.
Traders.
No, not traders.
I'm kidding.
It is 3,900 kilohertz.
Okay.
Let's take a look at the band chart here, and if we look at the 80 meter portion of that chart,
it said 75, but it's the same as 80. It's kind of pretty much the same.
If you zoomed on in on that, what would you see?
You would see this
that you
right
were
here.
Right. It does end at 4 megahertz.
Yeah, it does. And there's the general class. It goes from 3,800 kilohertz or 3.8 megahertz up to 4,000 kilohertz.
And generally, that's going to be the case on most of the ham bands. If you're a general, you're going to have the upper part of that band is going to be, you've got privileges for phone. But you can see if you're an extra class there, you're going to get roughly twice.
You get almost another 100%.
Yep. There's more generals naturally than there are extras. So 3,800 to 4,000 kilohertz there, that can get pretty crowded sometimes.
Oh, yeah.
And so that's one reason people would upgrade, past general. But most of your activity is going to be in that area right there that you will have privileges for.
Oh, cool. Nailed that one. Got lucky.
All right, well, ask me one.
Okay, how about this one right here? Which of the following frequencies is within the general class portion of the 80 meter band? A, 1,855 kilohertz.
B, 2,560 kilohertz.
C, 3,560 kilohertz.
Or D, 3,650 kilohertz. Okay, which is within the general class portion of the 80 meter band. It didn't say anything about the phone portion of it. It just said within the general class portion. Well, we know that the 80 meter band does not extend down to 1855 kilohertz. That's going to be down around the 160 meter band. We also know that it doesn't extend down to 2560 kilohertz. Let's see. C, 3560 kilohertz, or D, 3650 kilohertz. It's going to be one of those two. And I just happen to know that 3650 kilohertz is within the extra portion of the phone band that an extra has. But 3560 kilohertz, that's down in the CW portion of the band. And anybody that can operate CW in the 80 meter band can use that. You know, general, extra alike. I believe maybe even novice could operate there. I don't know. We'll have to look on that. But I'm going to say it's C, 3560 kilohertz. That's what they're saying over in the chat room. What do you think, Tommy?
I think that's probably right.
There you go.
Nailed it.
Yep.
No buzzer yet.
No buzzer yet.
We're 2 questions in.
If we look at our band chart there, back at 80 meter portion, you can see there 3500 to 3600. That's all CW there in that red. And
that's the general portion right here. 3525 to 3600.
Yep. 3525 to 3600. Novice and technicians can use that as well.
Sure can.
There's some HF privileges if you're a technician. Got to do CW there though.
Yeah.
So you can see 3650. The other possible answer falls within the extra portion of the phone privileges there on 80. So you don't get that. When general class licensees are not permitted to use the entire voice portion of a particular band, which portion of the voice segment is generally available to them? A, the lower frequency end.
B, the upper frequency end.
C, the lower frequency end on frequencies below 7.3 megahertz, and the upper end on frequencies above 14.150 megahertz, 14.150 megahertz.
The upper frequency end on frequencies below 7.3 megahertz and the lower end on frequencies above 14.150 megahertz.
Okay, this gets that's a lot of thinking to do there.
It is.
There's a lot of words in those answers.
This one's for me?
This is for you, yeah.
Okay, then I know the answer to that because I actually just said it a few moments ago.
Yep, I think you did.
And I didn't even know this was one of the questions. It's the upper frequency end. When we looked at the chart a few moments ago, you could see that all the voice was over on the high side of the band.
So you're saying number B?
I'm saying number B. And that's my final answer.
Well, I'm agreeing with you.
I don't need to phone a friend or anything.
Yeah. Everybody in the chat room's agreeing with you.
I need better glasses, though.
Yeah, they don't work if you leave them on the table.
Well, they don't work from there.
Okay. Well, hit me with your best shot.
All right, how about this? What is the DX window in a voluntary band plan? A portion of the band that should not be used for contacts between stations within the 48 contiguous United States.
B, an FCC rule that prohibits contacts between stations within the United States and possessions in that portion of the band.
C, an FCC rule that allows only digital contacts in the portion of the band.
Or D, a portion of the band that has been voluntarily set aside for digital contacts only. Well, let's see. The DX window in a voluntary band plan, there's your key word right there, voluntary.
Voluntary.
So it's in that case, it's not going to be an FCC rule, so we can immediately strike out B and C. We know it's going to be neither one of those. So it's either A, a portion of the band that should not be used for contacts between stations within the 48 contiguous states, or D, a portion of the band that has been voluntarily set aside for digital contacts only. Well, the DX window is not exclusive to digital contacts only. As a matter of fact, I think normally, I don't know on 80 meters anyway, the DX window is in a voice portion of the band. So I'm going to say the closest answer I see there is a portion of the band that should not be used for contacts between stations within the 48 contiguous United States. What do you think?
I agree with that.
Okay, it looks like the chat room is too. And that's correct there. An interesting thing, if we look back at our band chart there and look at the 80 meter portion of the band, the DX window starts at 3800, 3.8 megahertz, and extends down. So if you're a general, you don't really get to get in that portion of a DX window there.
Oh, that's true. I never thought about that.
Yeah, it's reserved for extras and advanced. If you hear some good DX down there below 3800, as a general, better not move down there and try to talk.
That's some incentive to upgrade to the next level.
It is.
To keep watching Ham College after we finish this.
Yep. Okay, well, we made it through those unscathed so far.
Mostly.
Well, I've got another one we're going to try and see how you do with this one. I think maybe this sounds like a familiar topic right here. Which of the following is a limitation on transmitter power on the 1.8 megahertz band? A, 200 watts PEP output.
B, 1000 watts PEP output.
C, 1200 watts PEP output.
Or D, 1500 watts PEP output. Okay, so some of the bands are for some modes limited to 200 watts, I remember. But I don't think it was down 1.8 megahertz, that's 160 meters. I think people run old broadcast gear down there, so I'm pretty sure D is going to be the answer for that one. 1,500 watts PEP output.
Okay, 1,500 watts. That's what most people are saying.
And the only reason I say that is because I said so.
Because that's the answer.
Yeah, I don't know how to reason that one out.
Well, you got it.
But I do know folks run some old broadcast gear down there
Yep.
for AM stuff.
They do. 1,500 watts PEP output. Referring back to our band chart there, if you'll look, the power on just about all of the HF bands here is 1,500 watts. And we mentioned that last week, with the exception of the 60 meter band, which is measured totally different, not even in PEP, but in effective radiated power. Mm-hmm. And there was one other band, Tommy, that you can't run 1,500 watts on.
I think it was 30, right there, 30 meters, 200 watts.
Yep, so you can't run it there either. So that makes things a little more interesting. 1,500 watts on just about all the HF bands there. You don't really have to worry about those two, 60 meters and 30 meters.
Yeah.
Other than that, you can run the maximum amount that a ham can run here. Well, we're going to take a break for just a moment here, get a message from Ikon, and come back and we got some contests to talk about.
All right.
Heard it, worked it, logged it. Contest season is here. Ikon's high-performance and innovative transceivers will help you make the most out of contest season. Continue your contesting momentum with the IC7300. Ideal for the ham on the go, it's a high-performance HF transceiver with a compact design, RF direct sampling, 15 discrete bandpass filters, large 4.3-inch color touchscreen, real-time spectrum scope, and SD memory card slot. The IC7851 will give you the competitive edge you've been looking for. Raise the bar and hear what others cannot with this HF 50 MHz transceiver. Reciprocal mixing dynamic range, crystal clear local oscillator design, spectrum scope, dual receivers, and digital voice recorder. And don't forget about the Ikon IC7700 and IC7600 radios. Both of these top-of-the-line transceivers are still available and sure to be the perfect companion for this contesting season. Visit IconAmerica.com/amateur for more information on all the great Ikon radios. We're going to give away something here. Tommy, what do we have to give away tonight?
Tonight, have...
right now.
Speaking of swag earlier, we've got a nice Ikon cap and an Ikon Ham Crew t-shirt. We're going to give away compliments of Ikon, of course.
Yeah.
So anyway, nice good t-shirt here. And I still need to hit Ray up for another one of these.
Yeah, you do. You keep saying that.
I just saw him a couple weeks ago too. I should have hit him up when I saw him. But anyway, how do you register to get these things again?
Well, that's a mighty good question there. And we got a website. No, we don't. We do have a website. That's
We do
not
have
how you
one, but that's
register
not
for
how you
this.
get one. We have an email address though.
We do. And that email address is
College at AmateurLogic.TV. Get your name in the drawing for next month, and you might win a Ikon cap and T-shirt.
Yep. And
Who won this time?
No particular requirements. You don't have to be a ham.
All you have to do is wear shirts and hats.
Mm-hmm. And you really don't have to have much in your email. And that's a good thing because our winner is David Hold, KE5ZZO. And that's all that's in his email. He didn't he didn't say anything else, but that's all he needed to say.
It says enough.
Yep.
Congratulations, David.
Yeah, congratulations, David.
Ikon will be reaching out to you to get your swag to you.
We got another contest to talk about. This one, you will have to be a ham to enter.
You do?
You won't necessarily have to be a general though, although it would help. You'll be wanting to upgrade.
Yeah, if you're not, you're going to want to be a general at least pretty soon.
If you won this, you would.
Yeah, I bet you can't guess what it is either.
Let me take a stab at it. I know that you can go to a particular web address and you can get more details about it. And that is AmateurLogic.TV/contest. Why would AmateurLogic be having a contest right now?
Well, you know, we've been around. We're the old kids on the block.
Yeah.
Probably more than one way than other. I mean, more than one way rather. But anyway, it's our 12th anniversary coming up in October, and Ikon's kind enough to sponsor us, along with some others. MFJ and How Sound.
Yep, and you need to go to this address, this one right down here, AmateurLogic.TV/contest. There you'll get all the details, a listing of the prizes, what you need to do to qualify, who qualifies to enter, all your pertinent information right there. We'll run over some of it here briefly though. What is going to be our grand prize this year, Tommy? It's going to be an HF base station, complete setup.
It looks a lot like this one right here.
The IC7300.
IC7300 from Ikon. It's just a fairly new radio. It's got the SDR. And
software-defined radio.
Really, really nice.
Yeah, I think this is probably the hottest radio going right now in HF.
Yeah, I had one at the house for a while, and I was got kind of ill when I had to send it back.
Yeah, the same thing happened to me.
Hard to pry this one out of our hands, but for you guys, we'll let it go.
Yep. Somebody's going to win that. Of course, they're going to need an antenna to go with it as well. And we've got the MFJ 1835 5-band cobweb antenna. That's the antenna that you used at field day. It
is. And you know what? For such a small, compact antenna, that thing really performed great.
And it is small for an HF antenna.
Yeah, I'm really happy with it. I'm actually considering putting one of them up at the house. So I've been having a lot of trouble keeping my wire antenna up.
Yep. So that's becoming a pretty popular antenna just because of the fact that it can fit into a small area.
Yeah.
Doesn't take a lot of room. You're also going to need a power supply. And what have we got for that, Tommy?
Well, we've got the MFJ 4230 MVP, 12 volt, 30 amp power supply. Really compact. I like those things. Doesn't take a lot of space and really puts out the power.
Small switching supply there. Works great. I've been using one of these for field day and any portable operations I do for several years now. And anything that runs off 12 volts you see on the bench here, it's probably running off that one right there. Then we got, you're going to need some coax. What can we do there?
Well, also courtesy of MFJ, we've got 100 foot of RG8X coax.
That'll work just fine. And we got one other prize here that our friend Bob Heil hooked us up with from Heil Sound. It's the ProSet IC. It's an operating headset made just for ICOM rigs. Dual earpieces. It's got a phase reverse switch here on the side where you can select normal or reverse phase, and sometimes it'll help one signal pop out of a pileup when you hit it to reverse. Somebody will come to the top and you can work them.
Oh, nice.
So that's why Bob added that feature on
pretty cool.
His headsets. Also, it's got the microphone designed especially to work with ICOM rigs, and an adapter cable to fit ICOM rigs. So thanks Heil Sound for supplying us with the ProSet IC here. Thanks ICOM, MFJ Enterprises, and Heil Sound for making this contest possible.
Absolutely. Really appreciate all those guys.
Yep. And this is not the first year they've done it, and we appreciate them.
No, they come through pretty well every year for us.
Year after year, helping us put these contests together. So let's talk about the qualifications. And you've got to be a U.S. or Canadian amateur radio operator with a U.S. or Canadian shipping address. We're just not equipped to do international contests. The laws are different in different countries concerning lotteries, and we're just not set up to where we can handle that. Sorry, foreign viewers.
Okay, well, also, there's only one entry per contestant. Sending more than one entry disqualifies the applicant. So please don't spam the contest address.
Right.
So
only send one.
Yeah, and you will get, just so you, for peace of mind, you will get an email confirmation that we did get it. So it's not just going off into a black hole somewhere and may or may not have made it. So you'll know. And
if for some reason you don't get that confirmation email, check your spam folder on your mail program. Perhaps somehow, the return email got blocked by a spam program. I haven't heard of that happening.
Very possible, though.
But, it could. And the winner is going to be responsible for any taxes that might be incurred.
Also, the winner agrees to the use of his or her call sign and name in promotional and news items related to the contest.
And contestants must not be an employee or affiliate of AmateurLogic, ICOM, or MFJ Enterprises, or Heil Sound.
Email to contest2017@AmateurLogic.TV and send your call sign in the subject line. Include your name, call sign, class of license, and an address in the body of the email message.
And you've got to make your submissions between Wednesday, August 16th and Wednesday, October the 11th of 2017. So that means you got a little while yet to register.
Yeah, still got a little while, but don't wait till the last minute.
And we're going to select the winner by a random number drawing. We're going to go through all the entries that we get. The first thing we're going to do, though, is we're going to look, and if somebody has entered multiple times, those are going to be purged so that no one will get an advantage from entering multiple times. As a matter of fact, you'll get excluded from the contest. And a random drawing, and it's going to be announced on the October 15th episode of AmateurLogic.
If it's determined the winning entry does not meet the qualification requirements, another winner will be chosen by the same method.
And you can get all the contest rules and information from AmateurLogic.TV/contest. Go there, check them out, get a list of the prizes and what you need to do to register.
Yeah.
Sign up and good luck, and hey,
good luck.
Happy birthday.
Good luck in the contest.
Good luck in the contest. Back to our questions tonight. We've got a few more band plan ones to go here before we get into a little electrical or electronic ciphering.
Okay.
First one here, I don't remember who asked the last one.
I think I asked it to you.
All right. Well, I'll be happy to ask you this. What is the reason why many amateurs keep a station log? A, the ITU requires a log of all international contacts.
B, the ITU requires a log of all international third-party traffic.
C, the log provides evidence of operation needed to review, C, the log provides evidence of operation needed to renew a license without retest.
Or D, to help with a reply if the FCC requests information. Okay, so the ITU doesn't require logs, so that's going to rule about both of those. And you don't have to have evidence of operation to get a renewal for your license. That's going to pretty well make it D, which is the only one that makes sense anyway, to help with a reply if the FCC requests information. So if there's an interference complaint or something like that, then you've got proof of when and where, frequencies you were on, so forth. How much power?
That's what everyone's saying over in the chat room, so that's the correct answer. Now, in my log, I don't keep a log of all the contacts I make. I'll put memorable ones in there. But I do put a lot of other details in there that won't be mentioned in the general rules here. I put different things like when I put up a new antenna, what the SWR measured on it. You know, any changes like that, I put them in my log also, so that I've always got a reference. I can go back and see if anything's changed.
Yeah, that's a good idea.
But, yeah, if you think you're going to need to remember a contact, or I would, you know, if you think it's going to be questionable that you might have to report to the FCC, then, yeah, you better put it in a log.
Yeah.
It's not
a bad practice to log them all anyway.
Well, it's not, but I mean, if you make a lot of contacts, common sense is most people are not going to do it.
Yeah.
If it's a DX contact or a contact made in a contest or something, there's a good chance those are going to get logged. But,
but that said, that is a good reason to keep a station log. In case the FCC needs information.
That is the answer you're going to need on the test right there. Okay, we got another question. You're going to check me on this one.
All right. What information is traditionally contained in a station log? Well, A, date and time of contact.
B, band and or frequency of the contact.
C, the call sign of the station contacted and the signal report given.
And D, all of these choices are correct. And it's going to be D because there's no one thing there that you would want to leave out. You know, all of those, traditionally, you'd put them in your log.
And in your case, and some additional things.
Yeah, I put additional stuff in mine because I'm a broadcast engineer, and that's
what you do.
That's what we do, yeah.
But it's not a bad idea, though, to log station changes, especially any kind of a major change.
It's definitely not. Matter of fact, it's a good idea, but that's not going to be on your exam. The answer is that, you know, all of those choices there were correct. Yeah, and they make sense. Every one of them does. All right, I got a question for you. What is the amateur auxiliary to the FCC? Is it A, amateur volunteers who are formally enlisted to monitor the airwaves for rules violations?
B, amateur volunteers who conduct amateur licensing examinations.
C, amateur volunteers who conduct frequency coordination for amateur VHF repeaters.
Or D, amateur volunteers who use their station equipment to help civil defense organizations in times of emergency.
Toughie, huh?
Yeah, I don't think it's a civil defense. It's not D. I don't think it's a civil defense organization. But that's like Mars Cap. Volunteers who conduct frequency coordination. That's the frequency coordinators. Never heard them called amateur auxiliary. And amateur licensing examinations. That's us. So it's got to be A, amateur volunteers who are formally enlisted to monitor the airwaves for rules violations.
Okay, well, that's what everyone's saying in the chat room. You go.
You know,
with
I
that?
don't recall ever really hearing that term though, but that's the one that makes sense for me.
Okay. Well, you were right.
Okay.
Okay.
Go figure.
Well, have you got a similar question for me?
I probably do. It's a good chance. Which of the following are objectives of the amateur auxiliary? A, to conduct efficient and orderly amateur licensing examinations.
B, to encourage self-regulation and compliance with the rules by radio amateur operators.
C, to coordinate repeaters for efficient and orderly spectrum usage.
Or D, to provide emergency and public safety communications. Which of the following are the objectives of the amateur auxiliary? Well, it's not to provide emergency and public safety communications. There are other amateur radio volunteer groups who do that, ARES, a number of others, but they're not called amateur auxiliary. To coordinate repeaters, well, no, that's a frequency coordinator. To conduct efficient and orderly amateur license examinations, no, that's a volunteer examiner. So that only leaves B, to encourage self-regulation and compliance with the rules by radio amateur operators.
Yeah.
That's
which is almost the same as the previous question. Very close.
That's what they're saying over in the chat room.
Must be true then.
It is. To encourage self-regulation and compliance with the rules by radio amateur operators. And there's good reasons for this, you know. The FCC more or less put amateur radio out there and said, you guys play by the rules and help regulate each other. We're not going to do it. We're only going to get involved when it gets really serious. But we're counting on you to take the burden of ensuring that, you know, people comply with amateur radio rules. And it's just, you know, it's good measure because the FCC doesn't have the resources to monitor, you know, nearly 800,000 amateur radio operators.
Yeah, so. And most of the time, other amateurs do a pretty good job.
They do,
for the most part.
But that doesn't mean that you go on the frequency. If you hear somebody doing something, you call them out on it and give them a thorough tongue lashing. That's not how it works.
No, that's not how it works.
No, not at all. It's, you know, as a matter of fact, they actually, if they catch you or happen to overhear you doing something wrong, usually you will get something in the mail saying, hey, we noticed on such and such a day that, you know, you talked for 3 hours without IDing or, you know, something like that. So, you know, it's kind of done in a friendly manner. You don't get a fine from that. It's just a notice that, you know, a notice of parent rules violation that, hey, you know, be aware of this. If you continue to do it, though, yeah, you might, you know, get somebody to drive up in a white van and knock on your door.
It's possible.
And that would be the Friendly Candy Company in that case. Okay, one more question here. And you can see now that we're out of the band chart questions, Tommy. Well, I'm not going to say that's all there was because
they keep creeping up every month.
Yep.
I wouldn't be surprised if another one or two didn't creep in there next month.
What skills learned during hidden transmitter hunts are of help to the amateur auxiliary? A, identification of out-of-band operation.
B, direction finding used to locate stations violating FCC rules.
C, identification of different call signs.
Or D, hunters have an opportunity to transmit on non-amateur frequencies. Okay, so this one's mine. And it's not D. We don't have opportunity to transmit on non-amateur frequencies.
No.
It's not C, identification of different call signs. I think it's going to be B. So let's look at A, identification of out-of-band operation. That's not something you would find on a fox hunt. Direction, no. B, direction finding used to locate stations violating FCC rules is going to be the answer. So in a fox hunt, They hide the transmitter. It's usually low powered, and people get real narrow beam antennas and go out and triangulate and find it, and that's what you would same method you would use. You had somebody having a key down contest over top of somebody or whatever.
Yeah. A violator. Yep, direction finding used to locate stations violating FCC rules. Yeah, hidden transmitter hunt would be great for that, or possibly finding someone in distress.
Yeah, absolutely.
That would be another good skill. Those are called fox hunts quite often.
Mm-hmm. And people are really good at that, So if somebody's out there doing some type of violation like that, people are really good at finding it.
Mm-hmm.
So.
Yep. Okay, we've got some more questions to go yet. First, we're going to take a break. Get a message from one of our sponsors, and who knows, maybe even a little Easter egg here.
Okay.
Are you new to the ham world or an existing amateur operator who wants to take your license to the next level? Study for your radio license exam at hamstudy.org. Hamstudy.org is a free online learning tool powered by Ikon. It was created by Richard Bateman, KD7BBC, Michael Stufflebeam, KV9G, and Rich Porter, KK6GKE, and it uses a modern web design to enhance the experience of studying for your technician, general, and amateur extra exams. Since 2013, hamstudy.org has helped new and existing hams to familiarize themselves with the question pools, use stats-based flashcards to focus on material they need to learn, and take practice exams to gauge progress. Visit hamstudy.org on your desktop computer or mobile device. Register for a free account at hamstudy.org to access personalized study history and other site features. Prepare for an exam in an intuitive and comprehensive manner. Check out hamstudy.org, powered by Ikon, for free learning tools. Good luck on your next exam.
Radio Shack has a super half-price deal now on an 8-track car stereo tape player. Regularly $59.95, now just $29.95. You save $30 and get your choice of music wherever you drive. Put stereo 8-track players in 2 cars for the regular price of 1. Or buy 1 and have enough money left over for car speakers and your first tape. Get on the road to savings now with this sale-priced realistic 8-track car stereo tape player. Only at Radio Shack, a Tandy company.
Leading television experts, cameramen, soundmen, engineers choose Motorola. Leading television stars like Ruth Hussey, Edward Arnold, and Lorraine Day say,
"See me at my best. See me on a Motorola."
Your eye tells why Motorola gives clearer, sharper pictures. For example, only Motorola has Glare Guard, the curved screen that eliminates up to 98% of all reflected glare. You'll find Glare Guard on the beautiful new Motorola's. Stunning consoles, handsome combinations, 18 Fashion Award-winning cabinet styles, like this Motorola Modern in Elsa Maxwell's smartly styled apartment.
On the other hand, you may prefer traditional furniture. You'll find no lovelier television cabinet styles than those created by Motorola. Motorola TV, the only television set to receive the Fashion Academy Award for beauty of cabinet design. For after all, when decorating your home, one of your first considerations must be the style and placing of your television set. Every Motorola, 4-way combination, stunning compact big screen table model, or any one of the handsome television consoles, whichever cabinet you choose will add to the beauty of your home. One of the reasons is Motorola's extreme care in selecting only the finest mahogany or rich-grained limed oak. Another reason, the painstaking finishing process, all done by hand, that gives your Motorola that soft, rich luster. The proof is in the seeing. Your dealer will gladly give you a free home demonstration of Motorola TV. Ask him about the truly generous trade-ins for your old set or even your old radio, and the terms are easy. 65 weeks to pay the balance after a small down payment.
Yes, for years of outstanding performance and beauty, Your eye tells why leading television stars like Lorraine Day say,
See me at my best. See me on a Motorola.
Motorola TV. Motorola TV.
Boy, that takes me back to the old days when we were in black and white.
Yeah, you know, I'd kind of forgotten we had been doing AmateurLogic for that long.
Mm-hmm. As a matter of fact, I don't know that I've ever watched a Motorola television.
No, I don't know that I have either.
Could have, but I don't remember.
But it had a really clear picture for that old.
It did, and it had the glare guard on it too. That's almost as good as a drizzle guard.
It was so clear.
Yeah. Well, we got one more thing we want to talk to before we wind up the last group of questions here, and that is an event that is coming up. See, this is August. It's coming up next month.
Oh, yeah.
It's our friends at MFJ Enterprises up in Starkville are celebrating the 45th anniversary. You know, we're celebrating 12 years on AmateurLogic, but Martin and the crew's been at it 45 years
Wow.
here. Yeah.
That's a feat in itself.
It is. It's the ARRL Day in the Park and MFJ 45th anniversary celebration. Come and join them on September 29th and 30th in Starkville, Mississippi. I'll be there. Tommy, you're going to be there.
I'll be there
too, aren't you?
Yep.
They got free prizes from MFJ, Ameritron, Cushcraft, High Game, Mirage, Vectronics. They're going to have the drawings on September 30th at 2 p.m. And you do have to be there to win. They got free factory tours, don't they?
They do. Interesting educational tours for the whole family at MFJ, Ameritron, Cushcraft, High Gain, Mirage, Vectronics, MFJ Metal Shop. Those are Friday, September the 29th at 8 a.m. to 4:30 p.m. and Saturday the 30th from 7 a.m. until noon.
And those right there make it worthwhile to attend, if not for everything else. That is... those factories are amazing to walk through and just see how they assemble all the different products.
Yeah, I said it last time, but I'll say it again. Those videos from when you went before and did the factory tour videos, those are some of the most watched videos we've had.
Yep.
They're very popular.
Yeah.
So you can see it in person.
I've been to this event twice, and I'm going back again this year. You know, it's that much fun. Free lunch, Mississippi Southern Fried Chicken and the fixings at McKee Park on Saturday, September 30th, 12 to 2. Bring your own lawn chair because, yeah, they will fill up. There won't be any place to sit down.
Yeah.
Yeah. When you get ham seating chicken, you know, that fills it up.
It draws the crowd. Okay, they also have free tailgating. Haggle and deal in the MFJ parking lot and also at McKee Park. That's on the 30th from 7 a.m. until 2 p.m.
And Arnie's Club is going to be there giving FCC license exams. The Lowndes County Amateur Radio Club VEs. So bring your government photo ID and $15 in American money cash. That'll be Saturday, September 30th at 9 a.m. You need to try to make it to Starkville. If there's any way you can do it, if you're within range, this is going to be a great event. You don't want to miss it. MFJ's 45th anniversary. Go to mfjenterprises.com/dayinpark.php. The link right here on the screen, because you do need to register. You know, they need to know how much chicken they're going to need.
Yeah, that's it's going to be a big time. Unfortunately, I don't think I'm going to be able to make it for Friday, but I will be there when they open up Saturday morning. I'll just have to drive in Friday evening. You'll be there Friday, though, won't you?
I am planning to be there Friday. If there's any way I can, I'm going to be there Friday. I talked to Wayne. You know, Wayne and I went to Huntsville this past weekend, and we were talking about that on the way over there. You know, we're both planning on being there, and I'm sure you'll see a lot of hams there. Arnie will be there.
Yeah, I went to a club meeting in Dallas, and somebody from there is actually planning on coming over to it. So
it's worth it. You know, Dallas, what, 8 hours away?
From there, yeah, probably so.
Okay, it's you know, you're going to enjoy this as much as you would any ham fest. It's just that interesting. Okay, back into the questions here.
Which of the following components should be added to an existing resistor to increase the resistance? A resistor in parallel.
B, a resistor in series.
C, a capacitor in series.
Or D, a capacitor in parallel. Which of the following components should be added to an existing resistor to increase the resistance? Well, that's pretty simple, Tommy. You're going to need a series resistor because you add resistors in series and that increases their value.
Mm-hmm.
So simple enough on that one. We covered that last time.
We did.
But this week we're going to talk about capacitors. Which of the following components should be added to a capacitor to increase the capacitance? A, an inductor in series.
B, a resistor in series.
C, a capacitor in parallel.
Or D, a capacitor in series. Okay, so the off-the-cuff thing, if you didn't know better, in the last one was had a resistor in series, you would almost think capacitor in series, but that's not how that works. So D is not going to be the answer. An inductor in series is not going to be the answer, and a resistor in series with the capacitor is not going to be the answer. So I'm going with C, a capacitor in parallel.
And that's what most everybody is saying over in the chat room there. I'll agree with you, capacitor in parallel.
Okay, I really like to go through these and reason them out, but I just don't really know how to reason that out for people. It's just something you kind of have to learn.
Well then, let me help you here.
Are you going to help me reason it out?
I'm going to help you do some reasonizing. Yeah. And I do want to mention one thing there. A, an inductor in series, that wouldn't increase the value of capacitance. What would it do, though? What if you put a inductor in series with a capacitor?
I'm thinking it'll increase the voltage, but I'm not sure.
No. It'll it'll counteract that capacitor because an inductance is right the opposite of capacitance. So, yeah, they will counteract each other. But it's the wrong answer anyway. So, parallel capacitors, the formula is the same as it was with resistors in series. Your formulas are exactly the opposite on capacitors from what they are for resistors. If you put capacitors in parallel, you're adding the capacitance.
The sum of all the ones that are in parallel.
Two capacitors in parallel, you're going to have C1 plus C2 will give you C total. Two capacitors in series, you would think like resistors that they add up. Nope, it's right the opposite. That's where you use that formula we had last month that caused so much trouble. Mm-hmm. Remember, 1 over the reciprocal of C1 plus the reciprocal of C2. You take 1 divided by C1 and you add that to 1 divided by C2. Get that number. Then you take 1 and divide it by that number. Using reciprocals there, that'll give you the C total for capacitors in series. You know, you never know when you're going to need a pair of 100 microfarad capacitors.
It's a good thing they just so happen to be exactly the same values.
Just so happen to be. And the larger value capacitors like these 100 microfarads, even on down as low as 1 microfarad, they're polarized, most of them. And if you look here, one leg is marked minus, the other leg doesn't have any marking. Sometimes it might have a plus on it.
Process of elimination would lead you to think that's probably the positive side, though.
Yep. So if it is a polarized capacitor, you want to be sure when you put it in the circuit, you put it in the right direction. Both of these say 100 microfarad on the sides. So let's just measure it. I'm going to put the black lead here on the negative, the red lead on the positive, flipper on the 200 microfarad scale there. Well, how about that? It's 92 microfarads.
What's the tolerance on that, 10%?
I'm not sure on these particular capacitors here could be a little tighter than that.
It doesn't look to be tighter.
Oh, I don't know what the tolerance is on my expensive Tenma capacitor checker either.
Oh, okay.
It's only about 20 years old and probably cost $30 back then. So it's not not the most accurate capacitor checker in the world. But let's check another one, see. Or maybe that was just an odd capacitor there. Maybe it's off a little bit. Well, we'll check another 100 microfarad. Almost exactly the same thing. 92 microfarads. Okay, well that's fine. That's close enough. That's within 10%. Okay, so if we take two of these and we hook them in parallel, I'm going to take the two negatives, tie them together, and we'll tie the two positives together. Okay, there you go. They're hooked in parallel. Positive, positive, negative to negative. We'll hook it on our meter here. What do you think it's going to read, Tommy?
These are parallel? It's going to read 50%. No, parallel. No, it's not. It's going to be 200 or close to 200.
All right, it'll be 92.
It's going to be 184.
Look at there. The theory works.
It does work.
The formula works. Okay. How's that opposite of resistors? Well, if you think about it this way, you're putting them in parallel. You know, a capacitor is just two groups of plates kind of almost touching each other, kind of interwoven there, but not quite touching each other. If you put two capacitors in parallel, you're putting twice as many of those plates beside each other.
Okay.
So it's increasing the capacitance. So a good way to remember that is why the formula is right the opposite of resistors.
Okay.
All right. Well, let's try it the other way here. We're going to take these and put them in series. I'm going to take the positive of one of them, hook them to the negative of the other one. And let's see, we'll only need one lead for this.
Oh, let's see.
So, in series this time.
And you just got a double expensive 50 microfarad capacitor.
Yep, 46 microfarads.
Pretty cool.
Yep, twice that would be 92. So, well, in this case, since there's only two capacitors, they're the same value. You know, it's going to be exactly half of whatever that value was. So there, we just proved out that the formulas work. What is the capacitance of three 100 microfarad capacitors connected in series? Connected in series. Is it A, 0.30 microfarads?
B, 0.33 microfarads.
C, 33.3 microfarads.
Or D, 300 microfarads.
What do you think?
Well, 3 in series is going to be the value of it's 33.3.
Well, I was hoping you would do some splaining.
Splaining?
Yeah.
100 divided by 3. That's not the long math.
That's not
the Tommy math.
Yeah, that's not the way you're supposed to do it.
But it works.
I mean, that works if they're all the same value. But if they're not, which will be the case, well,
they were in this instance.
Okay, if they're all the same value, I'll give you that. That works.
Okay.
Okay.
Okay. So what's the formula? I don't remember.
All right. It's 1 divided by
100.
100. All right, 0.01.
Oh, I can probably remember that. But
all right, so you need to add that together 3 times since you got 3 capacitors. Well, that is a different calculator, isn't it?
Yep.
0.03. Okay, now you need to say 1 divided by 0.03. 33.3.
33.3. The gazentas don't lie.
You know, you got that right. You knew right off what the answer was. So we're going to have to make them a little bit tougher here.
Uh-oh. What is the equivalent capacitance of two 5.0 nanofarad capacitors and one 750 picofarad capacitor connected in parallel? This is the single right here.
Between deca and deci. That's where units would be, or just a standard base 10 number. If you went up from that by 1 digit, you would go up to deca by 2 zeros, hecto. 3 would be kilo. We're talking about values you might see on a resistor. 6 would be mega, 9 would be giga, 12 tera, and that's the ones that you probably need to remember. Is 3 is kilo, 6 is mega, 9 is giga, and 12 is tera.
Okay.
All right, that's how many zeros are behind whatever the base number is. If you go in the negative direction, -1 would be deci, and the only reason that one's highlighted yellow is because of decibels. That's the only reason you would need that one. But coming on down, if you move the decimal places 3 places to the left, you've got milli. 6 places to the left would be micro. 9 places would be nano. 12 would be pico. So just remember 3 milli, 6 micro, 9 nano, 12 pico. Those are the most common metric prefixes that you need to remember. So you might look up a chart like this and study it.
And get a headache?
And yeah, but you're going to need that headache.
Yeah.
You know, you'll need to know this stuff.
When you get the chart, get you some Tylenol.
Yep. What is the equivalent capacitance of 2 5 nanofarad capacitors and one 750 picofarad capacitors connected in parallel?
2 5
right.
nanofarad.
Let's visualize that. These are in parallel. All right. 5 nanofarad. There's 2 5 nanofarad capacitors. And the other one is what? 750
picofarad.
Picofarads. And all of these are connected in parallel. Since they're in parallel here, that's going to be putting more plates on both sides like we talked about earlier. So I'm going to add these together. Mm-hmm. Well, some of the answers are nanofarad, some are picofarads.
Yeah, so we've got to figure out which one matches.
All right, so let's say 5 nanofarads, and I'm going to add to that 5 nanofarads, and then I'm going to add to that 75 picofarads. Well, the decimal place is right here.
That's 750 picofarads.
Okay. There you go, there's a 0. All right, 750. All right, so I'm going to need to move that decimal place to convert that picofarads to nanofarads. 1, 2, 3. So 750 picofarads is the same as 0.75 nanofarads. So 5 and 5 is 10 plus 10.75 nanofarads. That's going to be my answer.
10.75, yep.
There you go.
Right.
I was right.
Yeah, that one made sense. It was actually pretty straightforward.
Mm-hmm. You just got to know how to do the metric conversions there.
Mm-hmm.
But it was a little more complicated since some of your values were in nanofarads and some were in picofarads.
Uh-huh.
But study the chart, learn that, and you'll get these. Okay, so I'm going to ask you a series one here, just to keep it simple. What is the capacitance of a 20 microfarad capacitor connected in series? I'm not really making it simple, am I?
No, you're not.
What is the capacitance of a 20 microfarad capacitor connected in series with a 50 microfarad capacitor?
Okay.
If we looked at that right here, 20 and a 50,
right,
and they're connected in series, and they're both microfarads.
So that's divided by 20, I think.
Okay, 0.05.
Divided by, what was it, 50?
Mm-hmm.
One divided by 14.3 B.
So you're saying it's B.
So I'm saying it's B.
It is B.
I thought I graduated from school a long time ago, man.
Yeah, y'all wasn't
Of course, I'm back in college now.
Yeah.
I'm in Ham College, so.
Well.
But it works. It's really simple formula if you know what the formula is.
Yep. You have to be careful, though, because some of those wrong answers on there, if you calculate it the wrong way, you're going to come up with most of those wrong answers one way or another.
Oh, yeah.
So, you know, they're that tricky.
Unless you come up with 25.
Yeah, unless you come up with 25, then you luck out and you know it's wrong. An interesting point that was made over in the chat room here, when you're putting those in series, the value is always going to be less than the smallest capacitor you got.
Okay.
All right, so you got a 20 microfarad capacitor and a 50. You know the answer with them in series has got to be less than a 20. In that case, the only choice was 14.3. But
0.07 is less than 20, but it's a lot less.
Well, yeah, it's a lot less. So you did need to do the ciphering after all.
Yeah. What is the value in nanofarads of a 22,000 picofarad capacitor? A, 0.22 nanofarads.
B, 2.2 nanofarads.
C, 22 nanofarads.
Or D, 220 nanofarads. 22,000 picofarads, how many nanofarads would it be? All I got to do is move my decimal place 3 places to the left, right there. So I'm going to say
22 nanofarads.
22 nanofarads.
C.
C. Am I right?
I guess so.
Yep. Easy enough. Now we only went between picofarads and nanofarads here, so you know, you could also have it to microfarads. So what you got to learn from your chart there is picofarads is to the -12, nanofarads is to the -9, microfarads is to the -6. So you just got to move that decimal place to the left or the right. And it's always, when we're talking about capacitors and usually other components too, it's usually always 3 places you're moving either left or right, depending on which conversion you're making. What is the value in microfarads of a 4700 nanofarad capacitor? A, 47 microfarads.
B, 0.47 microfarads.
C, 47,000 microfarads.
Or D, 4.7 microfarads.
You want some pen and paper?
I can move 3 points in my head. It's going to be D, 4.7 microfarads.
Well, let's see, because it's easier for people to remember if we write it out.
Okay.
All right, you said it's 4,700.
In my head. I believe it's going to be 4.7.
All right, it's 4,700 microfarad or nanofarads. We want to move it to microfarad here. 1, 2, 3.
So 4.7.
That is correct. I like the way that you just did that right in your head right there.
Yeah, it's almost like I could see it.
Yep. I like, if it's on an exam, to put it down on a piece of paper like that and make darn sure that it's making sense to me.
That's probably best practice.
Yeah.
Actually, I'm sure it's the best practice.
Yeah. Well, yeah, unless you just do it every day and it's old hat to you.
And if you're doing the exam, you probably don't.
Yeah, true, yeah. So that was all the questions for tonight. But I'm just going to ask you a question here. Let's say I got a 10 microfarad capacitor. How many picofarads would that be?
How many picofarads? That would be 10,000 picofarads. How many nanofarads?
That's 10 That's 10 microfarads.
Microfarads.
All right, and you want to change it to picofarads.
10 million? That's not.
Microfarads is what, to the -6?
Yeah.
All right. So and picofarads is to the -12.
So that is
all right. So you're gonna you're gonna add 6 zeros.
10 million.
10 million. Boy, it
didn't seem right. That's why I was kind of second guessing myself. Yeah.
The little chart comes in handy there. I just happen to remember a lot of that from school. So, but
you
normally,
use this stuff a lot.
Yeah, well,
too.
I use it a lot. But if you don't, these charts are on the internet. It's so much easier today. In the old days, I would have had to pull out a book and look this up.
Oh yeah.
Yep. Matter of fact, I've got a Radio Shack data book in there that's just all marked up with pencil and crayons. From when I was in school, and that's that's the way you did it.
It's neat stuff, and I've been a ham for a long time, and I've only done just a very minimal of electronic stuff, and I'm really just now kind of starting to get into it a little bit. So I've been looking a lot of stuff up, on my own.
Well, you've been talking about possibly buying a real scope and function generator.
I'm going to buy one. I just got to pick out the one I want.
And asking some good questions about that stuff, too.
Yeah, so who knows?
Yeah. Do join us here in a couple of weeks for the next episode of Amateur Logic.
Yeah, that should be fun.
Yep.
If you haven't sent in your contest entry for the 12th anniversary contest, be sure to go online and do that. Yeah,
AmateurLogic.TV/contest. If you have done it, though, don't do it again and disqualify yourself. You're in there. If you've got a doubt about and you think you're registered, but you just can't remember, email one of us and ask us.
Yeah, we can check.
Yeah. All right. 7-3 all.
Yes.
See you again next month.
7-3 everybody. The upper frequency and on frequencies below 7.3 megahertz.
See those things right there? Yeah. I don't know if they'll work at that distance.
That's for wimping out. Right. Or D, the upper frequency and
end. I'm pointing at if you will load up that slide right there.
Is that what that means?
That's what that means. When I point at the thing that's highlighted yellow.
Well, you should have drawn a picture.
Yeah.
It said load up the picture.
Series capacitors. There is...
Come on, be serious.
Yep. That is not right.
Uh-oh. No, it's not.
That's not right at all. Where did you find that?
On the disc you gave me.